Hello, ladies and gentlemen. My name is Abdulrahman Ali from CCQ. Today, inshallah, I'm going to talk or explain a little bit about the gas turbine basics. An introduction to the basics of the industrial gas turbine generator engine. So we are having three categories: heavy duty frame and aeroderivative, and we have the gas turbine generator package, and we have the auxiliaries for the cogeneration or combined cycle power plant. Okay. Now, the gas turbine concepts. The basic gas turbine cycle. Everybody knows that the Brighton cycle is a very important cycle for engineer. Let's see the gas turbine cycle. Yeah, first of all, we are having the ambient air, which is here, the ambient air. It means the atmospheric pressure. It is coming here. Okay, this is the atmospheric pressure or atmospheric air. It's going to the compressor. Then the compressor, it's compressing the air. So we are going from stage 1 to 2, which is the compression stage. As written here, continuous compression states 1 to 2, the compressor requires power. So then it is going like this, compressing, compressed air up to here. Then the air goes to the combustor. Here is the second stage. From second stage to the third stage, here we call it the combustion side. What is happening here? The air is going to the combustor side here, and we add some fuel on this combust for combust the air, which produce a very high temperature. Okay, then it goes, this all hot air or combusted air, it goes to the turbine. Here from the turbine, it is stage 3. From the turbine up to the load, this we call it the expansion. What does it mean? It means here expansion back to atmospheric pressure, states from 3 to 2. The turbine makes power. So again, it comes back again to the same cycle. That's what we call it the Brighton cycle. So now, let's go to the second slide. Now the gas turbine basics also. Mechanical operating principles. The turbine section and its power output physically drives the compressor section, which requires power to operate. Excess turbine shaft power drives the load generator or mechanical drive pump compressor. What does it mean here? When we look at the turbine section, if it is attached to a generator, we call it load generator. Sometimes we are cancelling this generator, we are putting pump or compressor. In that case, we call it mechanical drive. Why? Because the turbine is rotating to rotate the pump or compressor for transferring purposes. For example, we are having a Dolphin company. They are transferring the gas or methane from Doha to الطويلة in Abu Dhabi. It is 400 kilometers just using this gas turbine or the mechanical drive. It is the first one in the world, by the way. Okay, now we can go to the firing temperature. Firing temperature T3 over time have climbed from 1400 degree Fahrenheit to 2200 and now 2600 Fahrenheit and beyond, with better turbine section materials, coating and cooling methods. High T3 equal improves power output and efficiency. What that means that here guys, see, T3 is actually located here. Okay, it's located here, T3. Why? Because the more hot air, it means that the turbine has more efficiency. So if it is 83, it means good. If it is 90, it means better. If it is 100%, which is impossible, but it means excellent. So the more number that we get in T3, it means we have a very good efficiency for the turbine itself. Now the pressure ratio, the pressure ratio is regarding the compressor side, which is here. This is the compressor side. So we can see the ratio here is 7.5 to 1, smaller and older technology GTs, and 35 to 1 or 40 to 1 recent most advanced GTs. See, there is a big difference between the old models and the new models regarding the compressors. So it means that inshallah in the future we are having better and better compressors regarding the pressure ratio. And now let's go to the aircraft jet engines or gas turbines. So the engines which is on the aircraft, we have three types. We have jet engines. They are propulsion via change in delta V momentum. And the second one, which is turboprops engines, propulsion via propellers. And the third one, low bypass and high bypass turbo fan engines, propulsion via large fans and jet delta V. All generally use high pressure ratio and high firing temperature, equal minimum weight and frontal area. So they are all having the same principles, no matter what, if you are jet engine, turboprop, or low bypass. Now, let's see. This is a nice diagram, but unfortunately it is in Fahrenheit. If it is in degree C, it will be much more better. Here, what is saying, the graph, that's the gas turbine inlet temperature trend. So it means that from 1940 up to 2000, we are having, a dramatically increasing, from here up to here. So our temperature or the inlet temperature trend, it is increasing. It means it's getting better and better. Now actually we are having higher or 3000 right now. That's the latest and the newest gas turbines. They are having 3000 Fahrenheit. So inshallah also in the future we are getting more and more. So like we said, if it is more the temperature or more higher temperature, it means higher efficiency. Thank you guys for watching. I hope inshallah you enjoy with me, and all the best and goodbye.